Joe Rogan has finally revealed the shocking image that the Webb telescope captured, finally showing what Oumuamua looks like. In 2017, astronomers spotted something unusual passing through our solar system. It was Oumuamua, the first known interstellar object to visit us. But what do the images of Oumuamua reveal about its true nature, and could these pictures change everything we know about the universe? Let's dive into the details and find out what this interstellar visitor can tell us about the universe beyond our solar system. Back in 2017, the world got a massive surprise. The Pan-STARRS 1 telescope in Hawaii, which is always on the lookout for strange events happening around the universe, spotted something totally out of the ordinary. It was Oumuamua, the first ever observed interstellar object to pay our solar system a visit. The discovery of Oumuamua set off many questions among scientists, and pretty much everyone who heard about it. People were fascinated for obvious reasons. Here was tangible proof that stuff from way beyond our solar system could come wandering in. And now, the James Webb Space Telescope has finally captured a shocking image of this object that has revealed its true nature. But Oumuamua wasn't intriguing just because of where it came from. This object had some pretty odd features that set it apart from the usual comets and asteroids scientists were used to seeing. For starters, its shape was something else. Most space rocks we encounter are somewhat roundish or irregular, but Oumuamua was long and skinny. It was a rock stretching out as long as a football field but with a fraction of the width. Then there's its path through space. Oumuamua zipped into our solar system at a speed, an angle that made it clear it wasn't from around here. It was moving so fast that it was just passing through. It did not get caught up in orbiting the sun like most space debris that comes our way. Perhaps one of the most puzzling things about Oumuamua was its lack of a cometary tail. Most comets have iconic tails of gas and dust that stream out behind them. Oumuamua didn't have one of those, despite getting pretty close to the sun, where you'd expect a comet to start spewing out material. This was a big clue that it wasn't your typical comet or asteroid. Oumuamua's arrival was like nothing we'd ever seen before. Its interstellar origin, unusual shape, and unexpected behavior had everyone from professional astronomers to casual space fans asking questions. What was Oumuamua really? Where did it come from? And what could it tell us about the universe beyond our solar system? So how did the James Webb Space Telescope spot this strange object? The James Webb Space Telescope is a crucial piece of technology in space exploration. Named after James E. Webb, the pioneering NASA administrator who played a crucial role in the Apollo missions, the telescope represents the next leap forward in space observatories. Its journey from conception to the final frontier is a tale of collaboration, innovation, and the unyielding human spirit. The idea for the James Webb Space Telescope began taking shape in the late 1990s as a successor to the Hubble Space Telescope, with the ambition of looking deeper into the universe than ever before. Developed through an international collaboration led by NASA, with significant contributions from the European Space Agency and the Canadian Space Agency, the telescope was designed to answer fundamental questions about the universe's earliest stars and galaxies, the formation of solar systems, and the potential for life elsewhere. At the heart of the telescope's capabilities is its suite of advanced instruments and a massive 6.5-meter primary mirror composed of 18 hexagonal segments made from gold-coated beryllium. This mirror is significantly larger than Hubble's, allowing the telescope to collect more light and observe objects in far greater detail. The telescope's design enables it to observe in the infrared spectrum, which is essential for looking back in time to see the first galaxies that formed after the Big Bang, as their light has been stretched into infrared wavelengths by the expanding universe. The telescope is equipped with 4 main instruments: the near-infrared camera, the near-infrared spectrograph, the mid-infrared instrument, and the fine guidance sensor/near-infrared imager and slitless spectrograph. Each instrument plays a unique role, from capturing detailed images to analyzing the chemical composition of celestial objects. One of the James Webb Space Telescope's most groundbreaking features is its ability to observe the atmospheres of exoplanets, potentially identifying signs of habitability or even life. By analyzing the light from stars as it passes through an exoplanet's atmosphere, the telescope can detect chemical signatures that may indicate the presence of water vapor, carbon dioxide, methane, and other key molecules. The telescope's path to the stars was not without its challenges, including technical hurdles, budget overruns, and delays. However, after years of meticulous planning, construction, and testing, the telescope was finally launched on December 25, 2021, aboard an Ariane 5 rocket from French Guiana. The telescope then embarked on a month-long journey to its operational orbit at the second Lagrange point, L2, about 1.5 million kilometers from Earth, where it remained shielded from the sun's heat and light, providing an unobstructed view of the universe. Since its deployment, it has begun to fulfill its promise, delivering breathtaking images and data that are reshaping our understanding of the universe. Its early achievements include capturing the most detailed views yet of distant galaxies, observing the atmospheres of exoplanets, and looking into dense cosmic dust clouds where new stars and planetary systems are being born. When Oumuamua came onto the scene, the James Webb Space Telescope became our best bet for getting a closer look. Its suite of instruments and unparalleled sensitivity to infrared light meant that it could capture details about Oumuamua's shape, size, and possibly even its composition that other telescopes couldn't. The build-up to the telescope's observation of Oumuamua was a major space event. Scientists and space enthusiasts alike were on the edge of their seats waiting to see what the telescope would reveal. The anticipation was about the broader implications. This was our chance to gain insights that could apply to other interstellar objects like it, perhaps even shedding light on the building blocks of other solar systems. It was a test of our ability to observe and understand phenomena from other star systems using the most advanced tools at our disposal. The insights expected from this observation had the potential to open up new frontiers in our understanding of the universe, making it a pivotal moment in the field of astronomy. Why does this object seize so much fascination? Since Oumuamua zipped through our solar system, it's been the star of quite a few scientific head-scratchers. One of the biggest debates is its shape. Initially, some thought it looked like a cigar, long and skinny. But then a new camp started arguing that Oumuamua might actually be more pancake-like, flat and wide. This goes to the heart of understanding Oumuamua's journey through space, and what forces it might have encountered along the way. Diving deeper, scientists have had all sorts of theories about what Oumuamua is made of and where it came from. One of the theories is the nitrogen ice hypothesis. According to this, Oumuamua is a chunk of nitrogen ice that broke off from a Pluto-like world in a distant star system. If true, this would explain its unusual acceleration as it passed by the Sun and tell us a bit about the neighborhood it came from. One of the most talked about theories is the idea that Oumuamua could be an artificial object, perhaps a probe sent by an advanced alien civilization. This speculation is fueled by its unusual acceleration as it passed through our solar system, which some scientists argue could be indicative of a light sail, a thin, wide surface propelled by solar radiation. While this theory leans more towards science fiction and lacks concrete evidence, it shows the huge impact Oumuamua has had on our imagination and our desire to find connections to other intelligent life in the universe. Another compelling hypothesis suggests that Oumuamua might be a fragment from a disrupted planet or a planetary building block known as a planetesimal from another star system. This theory says that Oumuamua could be a piece of a larger celestial body that was torn apart by gravitational forces, possibly during a close encounter with a star or a giant planet. Such an event could explain its elongated shape and unusual trajectory, as well as provide insights into the violent processes that can occur in young solar systems. The true nature of Oumuamua may remain elusive. Each theory contributes to a broader understanding of the processes at play in our universe. But with something as unusual as Oumuamua, it's easy to let our imaginations run wild. Oumuamua is weird, but jumping straight to extraterrestrial explanations without solid evidence isn't how science works. So as we piece together the puzzle that is Oumuamua, it's crucial to keep an open mind but also stay grounded. The truth about this interstellar visitor is likely to be strange enough without needing to venture into the world of science fiction. So what did the recent image captured by the telescope reveal that has had the science world so excited? When the James Webb Space Telescope turned its gaze toward Oumuamua, the anticipation was palpable. It was the first time we were getting a real up-close look at an interstellar object that had wandered into our solar system. The image we got was groundbreaking. For the first time, we saw Oumuamua as a distinct object with features and characteristics. The level of detail was unlike anything we could have achieved with previous telescopes. This was our first real glimpse of something from another star system, and it was as thrilling as it sounds. This image and the data that came with it started to give us answers. We could see the shape more clearly. The image supported the idea that Oumuamua was more pancake-like than cigar-shaped. This shape has huge implications for understanding how it might have formed and what processes it went through on its journey to our solar system. The data also gave us clues about Oumuamua's composition. The telescope's instruments detected signs of what might be surface materials, giving us hints about what it's made of and where it might have come from. This is crucial for figuring out whether it's a piece of a planet, a comet, or something else entirely. Oumuamua is the first of its kind we've observed, and now we have a clearer picture of it, literally. This image is a game-changer for astronomers. It means we can start to compare Oumuamua with other objects in our solar system and beyond, looking for similarities and differences that might tell us more about how our universe works. Oumuamua may just be a visitor passing through and giving us a brief look at the wonders of the universe beyond our solar system. But what a visitor it is! Its discovery, the questions it's raised, and now the new details from the James Webb Space Telescope have all sparked a wave of curiosity and excitement about the great unknown. Who knows what other interstellar travelers might be out there, waiting to be discovered? The universe is a big place, and we're just beginning to explore it. With every new discovery, we take another step closer to understanding the cosmos and our place within it. So the next time you look up at the night sky, remember, we've had a visitor from the stars, and it's changed everything.